For this lesson, we are going to be focusing on application of electrolysis. And so in application of electrolysis, we'll be looking at a few areas, including electroplating, extraction, and purification of metals. Okay, electroplating has to do with covering a metal with another metal in order to protect the metal. So we'll look at extraction and purification of metal too.
These examples of application of electrolysis. Okay, sometimes metals are gotten from the ground or extracted, and they may not be pure. Okay, so there's a need for further purification to increase the percentage purity. So electrolysis is one way of purifying metal, and it has been applied in the purification of metals. Okay, electrolysis are sort of being used in plating metals, using silver or gold to plate a metal, especially metals that can corrode, like iron. You can plate iron with silver or with gold. And of course, a very good use for electrolysis will be the extraction of metal. So we'll be looking at extraction of aluminium too in the next lesson. So, but basically, we want to focus on this interesting part of electrolysis, which is in the purification of copper. Okay, so you need to know that the ore, you know, of copper is called malachite. Okay, so but more often it is found combined with other elements, even though copper can occur in its native metal as native metal. When you say as native metal, we are saying that in its uncombined form, usually because copper it's a very least it's a least reactive metal. It's one of the least reactive metals, I should say. Okay, so but sometimes it can be found combined with other, you know, substance or element like sulfur, where you could have copper sulfide, you know, and the like. So we can use electrolysis to actually carry out extraction, you know, of copper, okay, in its pure form, by removing impurities and obtaining the pure copper. So the process is basically simple and quite interesting, interesting too. Okay, so if you remember what we've done so far under electrolysis, if for example you have copper sulfate solution, you would expect, okay, so copper sulfate can undergo electrolysis with electrode made of carbon or copper. Okay, so carbon electrodes are called inert electrode. They are called inert electrode. Inert simply means unreactive. Inert electrode means they are what? Unreactive. Okay, so because copper too has a kind of least reactivity, okay, so it could be used here. But if copper is used as electrode in an electrolyte that is copper sulfate, there is a kind of home advantage that copper is going to gain there, and that's a very good trick that is used in the electrolysis of what? Of copper. Okay, but let's look at this form of electrolysis in which the electrode is carbon electrode. No home advantage for copper. Carbon is the electrode. So if you have a container, okay, containing the solution of copper sulfate, and we have our electrode deep into this, okay, and you have copper sulfate there. So copper sulfate, like we've been doing before, will split into copper positive ion and sulfate what? Negative ion. Of course, since it's in a solution, then you would expect that you have hydrogen ion and what? Hydroxide what? Ion. So you have positive ions and what? Negative ions. Now this positive ion will migrate towards the negative electrode, which is the cathode, okay, and the negative ion will migrate towards the what? Towards the positive electrode, which is the what? Which is the anode. Now, two positive ions will migrate towards the what? Towards the cathode. Now, when they get here, there's going to be preferential discharge. If you look at your reactivity series, okay, if you look at your reactivity series, you will find out that your hydrogen is higher than what? Than copper. Because hydrogen is higher than copper. In this case, copper will be given preferential treatment because copper is weaker than hydrogen. So copper, when both of them get here, okay, both copper and hydrogen will get here, but hydrogen will be given preferential discharge. So copper will be given preferential what? Discharge. And so copper goes in to carry out, to represent the cathode. And what takes place at the cathode? That is reduction, which is gain of electron. Reduction, gain of electron. So copper goes in to gain electron, and it becomes discharged as what? As copper metal. So you find it being deposited on this. It's been deposited on this. So if this electrode, for example, were to be iron, and copper is being deposited on it, so you see at the end of the day, the iron is going to be covered by copper. So we call the process electroplating. I am plating another metal, covering another metal using a less reactive metal, okay, but the process is enabled by electricity, so we call it electroplating. Okay. So but on this other hand, these two will migrate, okay, hydroxide ion and what? Sulfate what? Ion, okay, because sulfate ion is higher in the reactivity series than what? Hydroxide ion. So hydroxide ion will be given preferential treatment. So hydroxide ion goes to the what? To the anode. Of course, remember we sang this like a song. 4 hydroxide will lose 4 electrons to form 2 water and 1 oxygen. So that's meant your hydroxide is discharged. This is the equation of that will happen at the what? At the anode. And of course, what's taking place here is what? Oxidation, loss of electron. But what taking place here is what? Is reduction, which is what? Which is gain of electron. Okay, so let me now look at the electrolysis of copper sulfate solution using copper electrode. Now we are giving copper home advantage. Let's see how that plays, out here. Now this is an electrolytic, tank for purification of copper. Now we want to purify copper. So the copper you want to purify will be at the positive electrode. Okay, the copper you want to purify will be at the positive what? Electrode. And of course the positive electrode here is called the what? Is called the anode. Why? The pure copper, a sample of pure copper will be placed at the what? At the cathode. Okay, that's a negative electrode. Of course, you want your copper pure, and so you won't put your pure copper at the negative electrode because copper is positive ion, and of course you know that positive ions will migrate towards the negative ion. So if I want to catch copper, I'm going to put the center of attraction at the what? At the negative electrode, because that is where copper will want to perch on, because unlike charges do what? They attract. So in this case, you put your pure copper, sample of pure copper at the cathode, negative electrode, and the impure at the what? At the anode. You see how this plays out. Very interesting. This is where chemistry gets interesting. Okay, so now when the cycle is connected, there's going to be a kind of migration. Okay, migration from this particular copper, impure copper, the pure copper part of this. Okay, because in solution here, copper will migrate towards the negative electrode. That's what is expected. Copper will migrate towards the negative electrode. So all the copper, just take it as a very simple form. Copper in the solution, or copper here as impure copper, so will leave this particular electrode and dissolve into the solution. Okay, so copper from this will go into and get what deposited at the negative what electrode, which is your cathode. Okay, so when they get to the cathode, they get what deposited. So essentially, you can see what's happening. After a while, this particular impure sample is reducing in size, shrinking in size, while this is getting bigger in size. So essentially, we can say that copper is migrating this way from this point to this point. Okay, so all the copper that's part of this, okay, Cu2 plus will migrate towards what? The Cu2 plus will migrate towards the negative what? Negative electrode. So basically, we still need to see the things that are happening at each of the electrodes. So let's look at it at the microscopic level now. So how is copper purified by electrolysis? So copper ions in the electrolyte are attracted to the negative electrode. That's first, the copper ions that are found in this electrolyte. Don't forget that the electrolyte consists of copper and what? And surface what? And sulfate ions. So they will be migrated towards this end. Now when this copper gets to this cathode, what's it going to do at the cathode? It's going to gain electron. So the copper gains electron there and will be deposited as what? As copper. The equation is very simple. 2 plus, okay, gains electron and deposited as what? As copper. That's why this is getting bigger and bigger. Okay, so the copper leaving this solution will be replaced by the copper from this what? From this particular positive what? Positive electrode. So because at the positive electrode, we need the loss of electron. So it is easier and it's more energetically favorable, okay, for copper metal to lose 2 electrons to become copper what? Copper ion. So the copper that is leaving this solution to get discharged as copper metal at this electrode will be replaced by copper metal leaving this particular electrode and being dissolved into the solution as what? As copper ion. So essentially, this solution remains the same while we have a net migration of copper from this impure end to this what? To this pure end. Okay, that is just the simple explanation of the purification of what? Of copper. So you may want to try out this review activity. Okay, 2, 3. Okay, yeah, negative electrode, and of course you have your redox equation. Okay, I'll see you in the next video where we are going to discuss about another application, which is the electrolysis of aluminum oxide, basically extraction of aluminum oxide.